Welcome, grade 11 mindsetters, and finally it's your turn. Grade 12s, don't forget, you can also tune in and learn more and learn extra. First of all, I want to start the show with saying a big up and a big thanks to the guys at Liberty who have made this show possible. We have Natasha taking us today. And today, Natasha, what are we chatting about today for grade 11?
Okay, so today, guys, we're going to top up your knowledge on quadratic inequalities, and it's one of those sections that is quite important and not enough attention is focused on this. So if you don't get it, you tend to miss out the little key points. So very good idea if you have any questions to send them through to Indiana.
Perfect, guys. So get chatting to us on Facebook. That's facebook.com/learnextra. Our Twitter handle is @learnextra. My name's Indiana. I'm sitting behind my computer and I'm here to answer your questions. I'm going to take a short break and we'll see you now. Hi guys, and welcome back. We are live. Grade 11s, make sure that you're tuning in and you're chatting to us on Facebook and Twitter. I'm Indiana and I'm here to talk to you on the page. Guys, I know that a lot of mindset is what they do is that they post questions on the page and we try and get through as many as we possibly can. But guys, I can't stress, if there's something that you know on the page and you feel like helping out a mindsetter, there's no reason why you can't. So if there's something that somebody is struggling with, type the answer, awesome, because that's what we're trying to do. We're trying to create a community of helpers and a community of mindsetters. So guys, I know Nell is tuning in. Let me know on the Facebook page if you're watching, what do you think of our new set? What do you think of everything that we're doing? We want to get to know you and send you amazing details. But let me have a look. Let's have a look and see what people are saying on the page. Sizwe, who won a calculator in the last session, said, wow, he can't believe he won the calculator. Thank you, Mindset Learn. He doesn't even have a calculator and he really needed one. So guys, you see, if you guys get chatting, talk to us, you could win a calculator too. We're giving away one in grades 11 and in 12 today. So there's still 2 more calculators to go. So get those questions in, even if it's something that you just want to say. Maybe it's a shout out to your friends or your family. Yeah, basically anything. This page is not only ours, it's also yours. I think what we're going to do is we're going to take a super quick break, and as soon as we get back, we'll start going over any questions you may have. We'll see you now after the break.
Do you sometimes feel like you're not getting the full picture? Or that your soccer ball is looking more like a rugby ball? Depending on the DSTV channel or program you're watching, you may want to change the aspect ratio setting on your decoder so that you get the best picture display possible. It's really easy to do. If you have a newer decoder, press Shift and TV Guide on your remote to access the arc or aspect ratio settings. Then select the one that works best. If you have an older model decoder, press the menu button. Select Advanced Options, followed by TV Installation for TV1, and then select the aspect ratio and viewing mode setting of your choice. If you have a widescreen TV, just make sure that it's not set to automatically adjust the picture, as this will clash with your decoder settings. Enjoy your viewing. DSTV, so much more for you.
Good evening, ladies and gentlemen.
And the winner is...
The winner is...
CNN and MultiChoice are proud to once again shine the spotlight on journalistic talent across the continent.
Thank you so much.
Entries for the 2012 African Journalist Awards are now open, and we invite all journalists to make their submissions before the 22nd of February. Log on to our website or visit your local MultiChoice office. CNN and MultiChoice, contributing to media excellence in Africa.
Don't you care about Downton?
I've given my life to Downton.
Why?
Chin chin.
I like living.
Just give the judge a couple of how you doings.
There, but for the grace of God, go on. I was a sap, and you're just like all the rest.
grade 11 mindsetters, and I've got a feeling it's going to be an awesome show. We're giving away a Casio calculator. We'll be doing that at the end. But without further ado, we're going to go straight to Natasha, and Natasha is going over quadratic inequalities, and I know that you guys are super excited. So Natasha, take it away.
Hi grade 11s, and I know that you're looking forward to this lesson on quadratic inequalities. You have already done quadratic equations. Now, just a quick reminder on what the difference between a quadratic equation is and a quadratic inequality. The most obvious thing being, in an equation you have an equality sign or an equal sign, and in an inequality you have inequality sign. So that's the most obvious difference between the two. The other thing is, in quadratic equations you have specific solutions. So you have x is equal to 1, 2, 3, whatever the case may be. But in quadratic inequalities we have intervals as our solutions. Alright, so before we start tackling the grade 11 inequalities proper, let's quickly do a bit of revision and tell you where we use quadratic inequalities. So quadratic inequalities are useful in graph interpretation, as I will show you in a second, but they also have the form ax squared plus bx plus c is less than equal to naught. So you would recognize that ax squared plus bx plus c, that is your quadratic form, and can either be less than or equal to naught, greater than equal to naught, less than naught, or greater than naught. Obviously these signs being your inequality sign. So let's just get a pen there so I can highlight that for you. So it can have any one of those forms. And so that's your basic notation, guys. So you need to remember that. That's the big difference between quadratic equations and quadratic inequalities. Now let's quickly look at revising interval notation. All right. So interval notation, you will remember from grade 10 that you can either get a closed interval. All right, so your closed brackets means that is a closed interval, or you can get an open interval. All right, and we'll discuss a little bit what this means. In a closed interval, the square brackets imply that you are not including whatever those end numbers are. Oh, sorry, you are including whatever those end numbers are, but in an open interval, which is your round brackets, you are not including those end numbers. So let's look at an example. Say I had on a number line the numbers 2, and say I had the number 5, and say we had an open dot. Remember, open dot means not including, over the 2, and then a closed dot over the 5. So if I were to represent this by interval notation, I would write it as x is an element. Remember, whenever you deal with interval notation, we are talking about real numbers. So we go x is an element, and we're not including the 2. So that's where we start with an open bracket from the 2, but we are including the 5. So to show that we are including the 5, we will close the interval at the end. Okay, so we can represent that solution. X is an element from 2 to 5, where 2 is not included and 5 is included. All right, so that's just one of the methods that you need to, well, one of the notations you need to remember when you're dealing with inequalities. You don't have to list your answers as interval notation, as I will show you now. The other option, if I wanted to write the answer x is an element from 2 to 5, I can also write it as x is less than equal to 5. Okay, you see what I'm doing? I'm including the 5 with the equal sign below the less than sign, or greater than 2. And there we don't put an equal sign because we are not including the 2. So these two are exactly the same solution to that interval. All right. Okay guys, so just remember, recap your grade 10 work. You need all of that stuff that you learned for grade 11 and then later on for grade 12. Now we're going to look at the different methods to solve quadratic inequalities. The method that I prefer is the number line method, which is what we're going to do first, but we'll also touch on the table method a little bit later on. All right, so let's look at the first example. Okay, that went up a little bit too quickly. Okay, so this is the number line method. Our example says x squared is less than 9, and in this kind of example, guys, you'd be asked to solve for x, all right? So they give you the inequality x squared is less than or equal to 9. What do we do? The first thing we do, just like in your quadratic equations, you isolate or bring everything to the left-hand side. So we move the 9 over the inequality to the left-hand side. So it becomes x squared minus 9 is less than or equal to 0. And as you see, just as in an equation, we have just a 0 on the right-hand side. That's always the aim. The next step is to factorize, and I know that all of you know how to factorize by this stage. All right, x squared minus 9 is a difference of squares, so I factorize that into x minus 3 times x plus 3. And I'm so glad, and I don't want to jinx this, but I'm so glad that this pen is not doing anything funny. Maybe I finally made friends with the pen. All right, so x squared minus 9, we factorize it into x minus 3 times x plus 3. And once we've got our factors, guys, what we do is we call those factors. We're going to find the roots of those factors. So in other words, what are the values of x? So x can be equal to 3 or minus 3 if this was an equation. Okay, but remember, it's not an equation. We use those as critical values. The critical values help us determine what's happening beyond certain points of those values and between those two values. All right, so our critical values here, I'm just going to say CVs, are when would x be equal to 0? It would be 0 when x is equal to minus 3, or when will the expression be 0? It will be 0 at minus 3 and then at 3. So those are the two critical values that we're looking at. We then take those critical values and we put them on a number line. So our number line, we list them from smallest to biggest. So we start with minus 3, that's our first value, and then the next value is 3. So we just arrange them in ascending order. And guys, what we're going to do now is, since we have the two critical values on the number line, we're basically just going to test the sign of this quadratic expression. So we're going to look and see what happens when x is certain values either to the left of minus 3, between minus 3 and 3, and then to the right of 3. So let's do that. If I take a number, any number, say we're going to start with less than minus 3. So if I take any number to the left of minus 3, okay, remember, left of minus 3, we're looking at numbers smaller than minus 3, so we're looking at minus 4, minus 5, minus 6, all the way to negative infinity. Also at this stage, remember, just going back here, we are looking for where our solution is less than or equal to 0. The only time this inequality would be equal to 0 is at our critical values, so at minus 3 and 3. Okay, so we just put dots over those two numbers to remind us to include those two numbers. All right. So I'm taking a number less than minus 3, although the minus 3 decided to disappear, so let's put that back in. So if I take a number less than minus 3, let's say minus 4, and what I do is I literally just substitute it into my quadratic inequality and see what the sign is going to be. Remember, all we're interested in is the sign. We don't care what the answer is. Okay, so if I look at minus 4 in the first bracket, minus 4 minus 3 would give me some negative answer. And minus 4 plus 3 in the other bracket would also give me a negative answer. Now, if you find the product of those two, so if you times them together, a negative times a negative will give me a positive solution. So therefore, what this shows me is that if I take any number, minus 4, minus 5, whatever number you want to choose, less than minus 3, the product of these two brackets is going to be positive. So therefore, what I do on the number line, I put down a positive sign for everything less than minus 3. All right, guys, we're then going to look at a number greater than 3. So exactly the same thing, so I'm not going to go over it the whole long way, just show you here what happens. So if I take a number greater than 3 and put it into the first bracket, so say for example 4 minus 3 would give me a positive answer, and then in the second bracket 4 plus 3 would also give me a positive answer. Let me just undo that. There we go. Okay, so if I take a number, for example, like 4 In the first bracket, I get a positive answer. In the second bracket, I'd also get a positive answer. And if I times the two positive signs together, a positive times a positive is a positive. So therefore, anything to the right of 3 would give me a positive answer. Now we're going to do exactly the same thing for any number between -3 and 3. We're just going to test any number, the easiest one obviously being 0. If I put 0 in the first bracket, I'm going to get just -3. Remember, we're just interested in the sign here, so not really the number, so it will give me a negative answer. 0 in the other bracket, I'll get a positive answer, and a positive times a negative is a negative. All right, so now we've got our number line of solutions. We don't have the answer yet. We know that all the answers greater than 3 would give us positive values. All the products less than -3 would give us positive answers. And everything between -3 and 3 would give us a negative answer. Now, if you look at your question, they ask you where the product is less than or equal to 0. So now we're going to actually answer the question. So we see the only time less than, remember, being negative, the only time that happens is here, between the values of -3 and 3. So therefore, to write it in, we'll do two separate ways. First in set builder or your general form, and then we'll also do it in interval notation. X has to be less than or equal to 3, or greater than and equal to -3. So that's where I will get the first, that's where my solution lies for me to get only negative products out of those two factors. All right? So guys, that's just our general format or our set builder notation answer. The other answer we can get, or we can write, if you prefer using interval notation, which I showed you at the beginning, we can say X is an element. Remember, here we're including the end value, so we start with a square bracket and we end with a square bracket. We're starting from -3 and we're going all the way to +3. So therefore, X is an element from -3 to +3. All right, guys, I still want to show you the graphical interpretation of this answer, but Indiana, do we need to take a break or can I carry on?
You know what? I think let's take a break, guys, but it's only going to be a short one. So guys, don't leave your seats. We'll be back with you in a minute. See you then. Hi guys, and welcome back. Can you believe that this lesson is flying? But they always do. You know what they say? Time flies when you're having fun. And fun all of you guys are having. I mean, thank you so much to all of you guys that are posting on the wall, and you're posting like crazy. They are, Natasha. But Natasha's going to finish off her question that she was on. So Natasha, take it away.
All right, guys. So just to continue from where we were, just a reminder that our solution here is X is an element from -3 to 3, or X is less than or equal to 3 and greater than or equal to -3. Those are the two different ways you can write it. So what I want to show you now is how we interpret this graphically, because the thing with quadratic inequalities is you might not get, I know you won't get a big exam question on quadratic inequalities, okay? What would happen is that they often infuse it into graphs and that kind of thing. So you need to understand how this ties in with quadratic functions. If you haven't done quadratic functions yet, now I know some grade 11s have and others haven't. If you haven't done quadratic functions yet, don't worry, I'm not going to go into too much detail, so you should still be able to understand. But if you have done quadratic functions, it's going to make a whole lot more sense now. Okay, quadratic functions, remember, being parabolas. So we said that our solution is X is an element from -3 to 3. To show you what this means graphically, now remember we started with x squared minus 9. That is the expression for a parabola. Okay, so if you think of the graph, y equals x squared minus 9, and you all would have done this in grade 10. Okay, that graph is a positive or a happy face parabola. Therefore, if I were to make a rough sketch of it, it's going to look like this. It's just going to be a happy graph. Okay? And what I'm going to do is just put an axis through it. Okay. At the points where the graph cuts the x-axis, those are the exact same values as our critical values. Those are the roots of the graph. So therefore, this point, the first point, will be -3. And then the second point is just going to be 3. All right, so that's the first x-intercept and that's the next x-intercept. Now, you can see that this graph has different shapes. We have, well, sorry, not different shapes, different signs. Everywhere between the point -3 and 3, we can see that it lies below the x-axis. So remember, anything below the x-axis in terms of signs is negative. If we look beyond -3, the graph is above the x-axis, so that's where it's positive. And then beyond 3, the graph once again is above the x-axis, so therefore positive once again. Okay, so in terms of our inequality, we were looking for where x squared minus 9 is less than or equal to 0. So in actual fact, what we were looking for is where this graph is negative or where it lies below the x-axis. So therefore, that happens everywhere between, okay, let's just try and get this in. Let's use another color. That happens everywhere between, okay, and I can't seem to get that right, so let's scrap that and I'll show you just manually. Okay, so everywhere between -3 and 3, you will see that the graph is below the x-axis, so that's where it is negative. So graphically, it makes sense. What we're saying graphically is that this parabola is only ever negative or equal to 0 between the points -3 and 3. All right. Now, I think what I'm going to do, Indiana, is I'm going to throw out a question there for all of the guys at home to attempt, and we'll get to it later on in the show. So shall we do that?
That sounds perfect.
Okay, guys. So here's my question for you, and it's one that comes on a little bit later. So I'm just going to try and find it. Okay. I want you to look at this question. You guys probably can't see it because it's right at the bottom of your screen, so I'm going to bring it up for you. The question says x plus 2. Remember, you're solving for x. So we're solving for x where x squared, where x plus 2 all squared, and this should be a times sign, times x squared plus 4 is greater than 0. Okay, guys, so hopefully you can all see the question. X plus 2 all squared times x squared plus 4 is greater than 0. My question to you is solve for x. What is the solution to this question? Where is this inequality greater than 0? And Indiana, I'm sure you can tell everyone where they can give us these answers.
Fantastic. Okay, guys, what you need to do is I'm going to post this question now during the break. And all you need to do is let us know. You can either post onto our Facebook page, which is www.facebook.com/learnextra. Paste them there on the page, or you can find our events wall, and that is the Learn Extra Live Grade 11 Maths Every Monday events page. So without further ado, I think we're going to go to a quick break, get those answers in, and we'll answer them towards the end of the show. See you in a bit, guys. Natasha has put up a question that I'm going to post onto Facebook now. But I think what we're going to go do first is go through a few questions, and then we'll go to the answer at the end. So Natasha, over to you.
All right, guys, just a reminder of the question, just in case you don't see it on Facebook. X plus 2 all squared times x squared plus 4 is greater than 0. I want you to solve for x. So tell me where you would get this solution, okay, as an interval. All right, now guys, I mentioned to you at the beginning that the other method we could use to solve inequalities, quadratic inequalities, was the table method. I'm not a huge fan of this, and many schools don't use the method, just simply because the number line is much, much quicker. But I'm going to show it to you just in case some of you still use this method. All right, so the example we're going to use here, we've got x squared is less than or equal to 4. All right. Okay, and the process initially is exactly the same. We take everything over to the left-hand side and we just have a 0 on the one side. So we're looking for where x squared minus 4 is less than or equal to 0. And I'm just going to now do exactly what we did with the number line method. We're going to factorize x squared minus 4. Okay, so once again, difference of squares as in the first example. So this is going to become x minus 2 times x plus 2 is less than or equal to 0. All right, and I'm just going to take down your challenge question. Hopefully you all have it by now. All right, so we factorized it once again. Work out your critical values or your roots. The critical values here are the values that would make this expression naught, so it's either going to be -2 or when x is 2. So those are two critical values. Now usually at this point what you would do is you would take those critical values and you would put them on a number line. What you can do instead is you can take those values and put them on a table. So then it's going to look like this. Okay, so we draw up a table, okay, with our two critical values. So I have -2, always arranging in ascending order, and then 2. Okay, and I'm just going to draw in the rows. Okay, and there are different variations on this table as well, but I'm just going to show you one of the methods. Okay, let's just get this out. So we have -2 and 2 as our critical values, and then what we're going to do is we're going to sort of set up the answers immediately. Remember, we're looking for where the product is less than or equal to naught. So everything to the right of 2, okay, remember 2 is the value that gives us naught, and -2 is also the value that gives us naught. Everything to the right of 2, we're going to say is x is greater than 2. Everything between -2 and 2, we're going to write it as x, all right, is less than 2 and bigger than -2. I'm just trying to squeeze that in there. And then everything to the left of -2, we write it as x is less than -2. Okay, and then what we do in the little rows below is we write down our two factors. So I'm going to have x minus 2, and then x plus 2, and then finally we're going to look at the product of those two factors. All right, and we do exactly the same thing where we were testing signs. Oopsie. In fact, I'm not going to do that. Just one sec. I just need one more column. Okay. There we go. And then I'm going to put those factors out instead on the side. So x minus 2, x plus 2, x minus 2 times x plus 2. All right. So remember, minus 2 gives us naught when we have the factor x plus 2. So we know minus 2 at x plus 2 at that factor, the answer is 0. And then 2, we know that we get naught at x minus 2. Okay, so I'm just putting it there to remind ourselves, and then obviously for both of them we get naughts at the product. Okay. If we take a number, x is less than minus 2, so any number x less than minus 2, and if I substitute that in one of the factors, so in x minus 2. So for example, if I take minus 3 and I put it into that factor, I'm going to get a negative answer. So if you take anything like minus 3, for example, put it in there, you get a negative answer. If you take a number between minus 2 and 2, so for example, if we take naught and once again put it into the first factor, I'm going to get just a negative answer. So I'm just going across the row. If I take x is greater than 2, so here any number greater than 2, so for example 3, and put it into the first factor, I'm going to get a positive answer. So what I'm interested in, once again, is just the signs in each of these. All right. Similarly, if I take x is less than minus 2, put it in the second bracket. So if I try minus 5, for example, my answer there is going to be negative. Any number between minus 2 and 2, so naught once again, I'm going to get a positive answer. And then greater than 2, so any number you 1, 2, 3, for example, I will get a positive answer. And then what we do with the final row, because now we've worked out our signs, okay? We've worked out what each of the brackets will give us as a sign when we test values to the left of minus 2, between minus 2 and 2, and then greater than 2. What we're going to do now in that final row is multiply those signs together and see what we get. So minus times a minus, our answer here is going to be positive. minus times a plus is going to give us a negative, and a plus times a plus is going to give us a positive. But guys, remember, you're looking for where the product is less than or equal to naught, less than or equal to being negative. So all we're interested in is where the negative solution lies. And that is between the numbers minus 2 and 2. All right, so we see that that answer from inside there, we write that as x is less than 2, but bigger than minus 2. So that we get straight from the table because we already wrote it out. All right, but remember here we were looking for where it was also equal to naught, so therefore we have to include the 2 end values. All right, we can also write this in interval notation as x is an element from minus 2 to positive 2. Remember, once again, when you use interval notation, we're including all real values of x, and you don't have to write both of these answers down, guys. You either put the interval notation in or the one with the inequality sign. So either x is less than equal to 2 and bigger than equal to minus 2. All right. Are we going to do another example, Indiana?
I think, yeah, I think we do. Well, I think we're going to go to an ad break quick. Guys, I know that there's a few questions that you have here on the page for Natasha. So please let me know exactly where you get lost or where you get confused so we can get through it a bit easier. So let's take a break. We're taking a break so we can prepare ourselves for the rest of the show. Someone was moaning, guys. So we'll see you now. Let's take a break. Yeah. Bye. Hi Mindsetters, welcome back grade 11s. Can you believe we've got about 15 minutes left this lesson? I know a whole bunch of you are freaking out a bit about the table method, but Natasha's going to take you through and she's going to help you understand another way of doing it. So without further ado, Natasha, let's get straight to it.
Okay guys, remember, as I said right at the outset, there's different methods to do quadratic inequalities. The table method is perhaps the most inefficient of the methods. The easiest one is really use the number line method. I just want to quickly go over to show you what the basic idea of the table method is, but really if it's a method that you're not comfortable with, then stick with the method that you know. Okay, so with the table method, what we do is we put our critical values at the top of the table, and then we put our factors to the left of the table. We then write down what the possible solutions could be. So if I'm looking at anything greater than 2, I write down that answer is going to give me x is greater than 2. All the values between minus 2 and 2 is x is less than 2 and greater than minus 2. And then all the answers to the left of minus 2 would be x is less than minus 2. So that top row, really what it's showing you is these are the specific answers. So if you got to the end and you look and say your answer was between 2 and minus 2, you already have what the inequality would be straight away. Okay, the body of the table, what we do there is we test different values by substituting values into our factors, and then we test the signs and see where we get positive or negative answers. But as I said, I don't want to go into too much more detail with that, and I'm certainly not going to do this whole example again with the table method because there is an alternative method. That method being the number line method. So let's do another example using the number line method. All right. So if I've got x squared is greater than 4x, the same thing that you would always do is bring everything over to the left-hand side. So it becomes x squared minus 4x is greater than 0. So once again, we isolate all of the variables and all of the numbers and everything onto the left-hand side, and we just have a 0 on the other side. All right, next step, which is always the same, is factorize. So remember to factorize this. I take out a common factor of x. So we divide through every term by x, and I'll be left with x minus 4 is greater than 0. Your next step is to find your critical values. Remember, your critical values are the values that make this expression 0. So the values where you would get a 0 or where your x is equal to 0 is going to be where either of these, so where either x is equal to 0, so where either of your factors is equal to 0. This is how we work out our critical values. So therefore, one of the critical values is 4, and then the other one is 0. So those are just really the solutions. If you were treating this as an equation, the solutions to the equations. Once we have our critical values, we then put that on a number line. Again, we arrange it from smallest to biggest. So we go 0 to 4. And guys, I'm just redoing the number line method just to show you how much easier it is than the table method. What we're going to do is we're going to remember, over here we're just looking at greater than 0. That's important. You've got to look at your inequality and look at what they're asking you. Here they're not asking you for an expression or an interval that's greater than or equal to 0. They just want to know where it's greater than 0. So we're just looking for where we get positive signs. We're not interested in values that would make this 0. So we're not going to include the 0 and the 4. They're going to be open dots. All right. So once again, we test value. So if I take any number greater than 4, so anything to the right of 4, so for example 5, if I put it into the first factor, it's going to give me a positive sign. And then if I put it into the second factor, once again, I'll get a positive sign. A positive times a positive is a positive. So therefore, any number greater than 4 is going to give me a positive product. If I take a number between 0 and 4, so for example, let's take 1. If I put 1 into just x, obviously it's going to be positive. If I put 1 into the bracket, I'm going to get 1 minus 4, which is negative, and a positive times a negative is a negative answer. Then if I take any number less than 0, so to the left of 0, so for example, minus 2, my first factor would be negative. The second factor would also be negative, and a negative times a negative is a positive. Okay, or let's just put it on the top there so we're consistent with what we were doing on the other side. All right, so guys, we see that our solution to the right of 4 is positive. Our solution to the left of 0 is positive, and everything between 0 and 4 is negative. But remember, the question asked, where's the product? Positive. So therefore we're looking for a positive sign, and we can see that the positive signs lie to the left of 0 and to the right of 4. So therefore, to write this as a solution, it's going to be x, and once again writing it as an interval, not as an equal to in an equation. So x is either going to be less than 0 or x is going to be greater than 4. Okay, so any number to the left of 0 or to the right of 4 will give us a positive product. All right. Okay, so hopefully you guys are understanding the number line method. If not, please let us know. But what I'd like to do now is to have a look at that challenge question that I threw out there. And Indiana, you can tell me if we've had anyone get it right or attempt it.
We have had quite a few people attempting it. Some of them were a bit confused about what the outcome should have been. But I think, guys, let's just watch Natasha solve it and work through it, and we can all work through it together. And let's see if anyone got it right.
Okay. All right. So, guys, remember here, when you're doing quadratic inequalities, you're solving for an interval of values, and you're looking for where something is positive or negative. That's the only two options. You're looking for a positive or negative solution. All right. That's it. And if we look at the challenge question that I gave you, so let me just go back up and try and find that. There we go. Okay. It was x plus 2 all squared. And remember, we're solving for x, but our answer is going to be in an interval, not as a specific value. So we're looking for where x plus 2 squared times x squared plus 4 is greater than 0. All right. So guys, if you try and do this in the normal way that we've been doing it all the time, and we say, okay, let's solve for x, let's find the critical values and then do a number line, it's not going to work. Because if you look at x squared plus 4, all right, and this is the reason it's not going to work. If we look at x squared plus 4, and if I'm trying to find the solution to that, if I make that equal to 0, I'm just going to get x squared is equal to negative 4, and we know that we can't do anything, we cannot do anything with that, because you can't have a positive number equaling to a -1. Or if you want to think of it another way, we cannot take the square root of a negative number. That's not allowed. So therefore, since this x squared plus 4 has no solution, that means straight away it rules out our number line, our traditional number line method. All right, so what we're going to do is let's analyze each of the factors here. If we look at x plus 2 all squared, all right, hopefully you guys can see that the sign of x plus 2 all squared, this square, means that everything inside this bracket will always end up positive. It's always going to be greater than 0. I'll always get positive answers. Think about it. If you put, for example, put in the biggest negative number you can think of, put in minus 100 or minus 10 million or whatever you want to, and we add 2 to that, but then we square it. It doesn't matter how negative that big number takes it. The fact that we're squaring that entire expression means we'll always end up with a positive answer. All right, so therefore, x plus 2 all squared is always going to give us a positive answer. It doesn't matter what x is. When it doesn't matter what x is, hopefully you know and you're shouting out at home, what do we say? When it doesn't matter what x is, we say x is an element of real numbers. Okay, so that's the first factor. Okay, if we look at x squared plus 4, and I'm going to have to go onto another page here. All right, I'll just rewrite the question for you. So we had x plus 2 all squared times x squared plus 4, and we're solving for x. We want to find out where this is greater than 0. So we said the first bracket is always positive, simply because of the square outside the bracket. Similarly, if you look at x squared plus 4, all right, if you take any number whatsoever and put it into this x, so if you take minus 1,000 and you square that and then you add 4 to it, what you will notice is that this square takes care of the negative. It always turns that into a positive answer. So therefore, x squared plus 4 is also always going to be greater than 0. It's always going to give you a positive answer. So therefore, if the first bracket is always positive and the second bracket is always positive, the product of the two is always positive. So in other words, the solution is x is an element of real numbers. So x can be any number it wants to, because we are always going to get positive answers. All right. I can also explain this to you, just the second one, x squared plus 4, in terms of graphs. Remember, you're looking at a graph, a parabola that's floating above the x-axis. It's always going to be greater than 4, never below 4. So therefore, that's always going to give you positive answers, and similarly with x plus 2 all squared. So guys, hopefully you got that answer and you got that x is an element of real numbers. If you did, very, very well done, because it is a little bit of a tricky question. All right.
It was a bit of a tricky one. Natasha, we've got about 3 minutes left. I don't know if you've got time to maybe go over another linear problem, or whether we should take questions.
All right. Does everyone understand everything so far?
They haven't written back to me yet about this question, guys. So guys, let me know, because I can always let you know again on the Facebook page. That's okay. Let me have a look here. I mean, there's lots of comments here that everyone's saying that we're doing a great job, and amazingly, some people find the table easier than the linear. But then,
it's possible.
But don't worry, the other way around as well. So we've got a good handful that like both. I think maybe what's the best thing to do is do we have time to go over a quick linear question?
We don't. Also, guys, what I just want to remind you that linear inequalities are completely different from quadratic inequalities. If you were struggling with linear inequalities, you must be in grade 10. We do not do linear inequalities in detail in grade 11. We only focus on quadratic inequalities. Linear inequalities are just straightforward, where you take isolate the x, take the number to the other side. It really is quite straightforward. I just want to recap quickly what we've done in quadratic inequalities, which was really just show you that it's essentially used in interpretation of graphs. Specifically in grade 11, you look at parabolas, and it helps us to determine where the graph is positive and where the graph is negative. Okay, also remember you can use interval notation to represent your answer, or you can use set builder notation. Set builder notation just being your traditional solution of x is less than something and bigger than something else. All right, so you can use interval notation, you can use set builder notation, but most importantly, and a lot of pupils sometimes they get to grade 12 and for some reason they forget this, especially when they get to trig graphs. When we ask you where a graph is positive or negative, don't ever, under any circumstances, say x is equal to. As soon as you see x is equal to, it's wrong. Remember, when we're asking you where a graph is positive or where it's negative, you're always looking at intervals and you're always looking at writing it as inequalities. All right.
Fantastic. Thanks, Natasha. I think that was a nice little bumper, a little bit of information. Guys, I want to say, grade 12s, don't forget you're on next. I know that there's a whole bunch of you, Lebza and Nelly, have all been waiting for the grade 12 session. So grade 12s, you're on next. Grade 10s, thank you so much for a fantastic session. I'll be letting the winner know who won the calculator after the session on the Facebook page. So for today, we're out. Bye, guys.